Hi to everyone. Today we are discussing about Engineering Mathematics 3 under the topic differential equations. Today topic is linear differential equation of first order. Linear differential equation of first order. Okay. In this previous session, we will discuss about homogeneous differential equations and before of this homogeneous equations, we will discuss variable separable. These topics are you discuss. Two methods are completed. So today, three methods are completed. Today you are discussing about linear differential equation of first order. Okay, in this topic, we have to discuss about linear differential equation definition. So today learning objectives are identify the linear differential equation of first order. How to identify the linear differential equation, we will see in the session. To know the meaning of integration factor. What is the integration factor? We will know about it. So calculating the integration factor. How to calculate the integration factor? We will discuss. Next, write the general solution. What is the general solution? What is the formula for general solution? We will discuss in this session. So these four topics we will discuss in the session. So today I am going to teach about this linear differential equation of first order. See this. So today we learned in the previous session. What we learned in the previous session, I will review once again. So variable separable. And second one is homogeneous and equations reducible to homogeneous form. Okay, if the equation is not homogeneous, non-homogeneous equation, we have to reduce the equation into homogeneous form. Then after the procedure of homogeneous form, you will get the required solution. It will be form to variable separable. Then after integrating, you will get the required solution. So next, another topic is exact differential equations. So these topics we will discuss in the previous session. Variable separable also completed, homogeneous completed, and if the given function is not homogeneous, then we have to reduce the equation into homogeneous. Then after variable separating the variable, then after apply the variable separable method, then you will get the required solution. So the third method is exact differential equation. This is also completed in the previous session. Today we will discuss about the linear differential equation. See here, what is the linear equation? We will know about the definition of the linear differential equation. Okay, a differential equation is said to be linear when the dependent variable and its derivatives occur only in the first degree and no product of the terms occur. Okay, I will repeat once again. A differential equation is said to be linear. A differential equation is said to be linear when the dependent variable and its derivative occur only in the first degree. Compulsory, the differential equation is in the form of first degree, and no product of these terms, no product of other terms. Okay, these terms. So I will give clarity to see here. An nth order differential equation with depends variable y is said to be linear. An nth order differential equation with the dependent variable y is said to be linear. Then we have to satisfy these conditions. I will give and show here. Y and all its derivatives are derivatives of degree 1. Compulsory, all derivatives y variable and all its derivatives are of degree 1. Compulsory, it should be 1. Y variable value and differential equation value compulsory degree is 1. So no product terms of y and or of its derivatives occur. No product terms of y and or its derivatives occur. So if it is not having the derivative of y to the function dy by dx, okay, no need to write that equation. So next, no transcendental functions. Transcendental function means sin x, cos x, log x, e power x, etc. Those are transcendental functions. No transcendental functions of y and or its derivative present. So in this equation, we need not to write transcendental functions, log x, sin y, cos y, next e power x, just like. Okay, if there is not appear this transcendental equation in this given differential equation, and y power and derivative of the power is only 1, and not appear in the product term with y with dy by dx, then the equation becomes a linear differential equation. So these three conditions are satisfied, then the equation is called linear differential equation. See here once again definition. A differential equation is said to be linear differential equation when the dependent variable and its derivative occur only in the first degree. No product terms of this occur. Clearly given here, no product terms of occur and first degree. These conditions must and should okay, satisfies, then the equation is called linear differential equation. So now we will discuss about non-linear differential equation. What is the non-linear equation? A differential equation is said to be non-linear equation if it is not linear. If it is not linear, I'm telling not linear, non-linear not. If the differential equation is said to be non-linear, if it is not linear, then the equation is called non-linear differential equation. See the definition? The differential equation is said to be an non-linear differential equation. Non-linear differential equation if it is linear. If it is not linear, okay. So the a linear differential equation, LDE means linear differential equation, is of first degree only, but every first degree in a differential equation need not to be linear. Since it may contains y square, y to the power of minus 1 by 2, e power y, and sin y, etc. They may not contain, it may contain y square, y to the power of minus 1 by 2, e power y, sin y. These are called transcendental functions. So in nonlinear differential equation, it will be contained. In linear equation, it not contains. Okay, so I will give some example of nonlinear. See here, e power x is there, e power y is there. So dy by dx is multiplied with e power x, dy is multiplied with e power x. So here this is a transcendental function having in the differential equation. That's why it is not a linear. Only we have to write only y terms only, y with multiplied with dx. That's all. So and its degree is only 1. So here is y power degree 2 is there. So it is a non-linear. We want to take only y only, not product. Okay. So these rules we will identify. Next, integrating factor. What is the integrating factor? We will discuss once again. An integration factor is a function which, when the differential equation is multiplied to become an exact differential equation. A differential equation is multiplied with one function, then the differential equation becomes a exact differential equation. See here, and integration factor is a function which, and when the differential equation is multiplied with integration factors, it becomes an exact differential equation. Then that's easy to solve the solution of this exact differential equation. Okay, that is the integration factor. So I will give one example. So consider 2xy square minus y into dx plus x dy is equal to 0. 2xy square into dx plus x dy minus y dx is equal to 0. So can't find a solution. Can't find the solution. Why? See here. But when we multiplied the above equation with sides by 1 by y square. When this equation multiplied with on both sides with 1 by y square, then it becomes a exact differential equation. Then it will be solved. It will be easy to solve. Okay. So here is y square term is there. You will need only y x term only. Okay. It will remove from this equation. Then it will be modified to the exact differential equation. See here, I am multiplying with 1 by y square on both sides. Here 0 in something is 0. So next this equation becomes 2x dx, y square cancel, minus y dx minus dy, d by dy of y square is equal to y of y square is equal to 0. So now simplify this one. This equation can be written as integration of u x by y, integration of x by y formula. Already you know derivative of x by y formula. Already you know v into derivative of v into derivative of u minus u into derivative of v by v square. Using that formula, this can be written as derivative of x by y. You will expand this equation, then you will get this one. So now it is ready to integrate. See here, integrating on both sides, we get integration of two constant take common. Integration of x is x square by 2. 2 to get cancelled, and integration we are differentiating okay, to y minus here derivative integration get cancelled. You will get x by y. After cross multiplication, you will get here y value. Y minus x is equal to this denominator y multiplied with this here also y. So I will give that once again. See here, integration of 2x dx. 2 is constant. Integration of x value is x square by 2. So 2 to get cancelled, you will get x square only. So this y comes from this second term. So integrating this equation, integration derivative will be cancelled. These are opposite terms. So you will get integration of x by only x by y will get. So after taking LCM, you will get x square into this y minus only you will get x by y. Y is cross multiplication of this c, you will get cy. This is the required solution. Okay. Here the factor 1 by y square is an integration factor. So if the given differential equation is multiplying on both sides with respect to both sides with 1 by y square, the equation formed to the exact differential equation, then it is easy to solve. Okay. So here 1 by y square is the multiplication factor of the differential equation. It is easy to make the equation exact equation. That's why we are defining this is integration factor. Okay. So linear differential equation. What is the linear differential equation of first order? We will discuss now. A differential equation of the form dy by dx plus py is equal to q. See the observe this equation. I will discuss in the above PPT. See here. See here y power 1. The differential equation of degree is only 1. And here y power 1. So this is the linear differential equation. First you have to check it is a linear or not. Okay. From this equation where p and q are constant, where p and q are constants, are functions of x alone, is a differential equation of first order in y. Differential equation of first order is y. If this q of x is equal to 0 for all x, then the homogeneous linear differential equation is otherwise non-homogeneous linear differential equation. Okay, q of x is equal to 0 for all x, then it is a linear differential equation. This homogeneous equation is linear differential equation. Otherwise, it is not equal to 0. It is a linear differential equation. The given non-homogeneous equation is linear differential equation. So depending on this qx term, it is a linear or it is a non-linear. We have to identify. Okay, I hope you are understood. So I will go to another topic. To solve dy by dx plus py is equal to q. This is the linear differential equation formula where p and q are the functions in x and y. Functions in x and y is mixing. Where p and q are only in the variable x only, not y. Okay, dy by dx plus py is equal to q. Dy by dx plus py is equal to q. Name this equation. Here, multiplying this equation on both sides with the integration factor e power p dx. The formula for integration factor is e power integration of p dx. This is the formula for integration factor. Now, this you have to multiply it on both sides this equation by integration of e power integration of p dx. Okay. So on both sides you will multiply. Then the equation becomes dy by dx into e power integration of pdx plus py into e power integration of pdx, and right side q into e power integration of pdx. Here is x is missing. Okay, sorry, into. Okay, not x, into q into e power integration of pdx. This is the equation number 2. From this equation, but dy by dx into y into e power pdx is equal to dy by dx into e power integration of pdx plus py into e power integration of px. Okay, see here, integration of derivative of y into e power pdx is equal to q into integration of pdx. So these are equated. Then the integrating we get integrating on both sides we get. So v into y into integration of pdx is equal to integration of q into e power integration of pdx into dx plus c. Okay, after integration, you will get this derivative integration get cancelled. You will get only y term. This e power integration factor. This is the integration factor. This is the solution for linear differential equation. Okay, this is a general solution for linear differential equation. So this can be written as y into integration factor is equal to integration of q into integration factor into dx plus c. This is the general solution for linear differential equation. Okay, where integration factor is integration of e power pdx is the integration factor. When we multiplied the homogeneous differential equation with the integration factor, it becomes a linear differential equations. Okay, that is the logic. So we will discuss about the working rule of the linear differential equation. What is the working rule of the linear differential equation? We will discuss now. Okay, see here. So working rule to solve the linear differential equation of first order. See here. Rewrite the given equation in standard form dy by dx plus py is equal to q. Dy by dx plus py is equal to q. Identify p of x and q of x from the above equation and find the what is the integration factor you have to find. Then write the general solution as integration factor is equal to integration of q into integration factor into dx. Then finding this all terms, then substitute in this equation, we will get the required solution. The another form of the linear differential equation is dx by dy. We will see before dy by dx. Here dx by dy. So dx is numerator, dy in denominator. Plus here is in the above equation you will get py. Here px. So the difference between the two differential equation is dx by dy plus px is equal to q. The above equation is dy by dx plus py is equal to q. This is the another form of the linear differential equation, where similar process you are in the similar process you have to find p and q functions. Those are in y variable and constants. So the general solution is given by in before problem we have taken here y. So this other form you will get x into integration factor is equal to integration of q into integration factor into dy. Before dx we are taking dx, the above form. In this form we have to take here dy plus c. We are integrating with respect to y. That's why we are taking y. This is the general solution of the above differential equation. Okay. So where integration is factor is e power integration of pdy. Okay, right. While finding the integration factor, use the uh, use the following formula: e power log of f of x, e power log of f of x. Then we can write f of x. You know already in logarithmic function we discussed in first year. E power log value is always 1. E power log e base e value is always 1. Okay. So when this equation is appear, we will write directly the solution is f of x. Next, e power 2 log f of x. Then here m log x is in the form of m log x. This take this 2 on f of x square. Then it becomes e power log. E power log value is 1. You will get here x square. You will get here x square only. F of x square only. So m log x power m. So here e power log value is 1. You will get only f of x whole square. Then e power minus log of f of x. So this is in the form of m log x. Take this power on f of x power. You will get e power log of f of x power minus 1. This e power log value is 1. You will get f of x power minus, can be written as 1 by f of x. Take in denominator, you will get 1 by f of x. So now integration of t into e power d dt. T into e power dt. Using by integration by part formula, you will get t minus 1 into e power t. Using by integration by part formula, already you know u into dv. Integration of u into dv is equal to u into v minus integration of v du. That is the integration by part formula. We will discuss in the integration chapter 1. Okay. Next. Now this can be written as directly t minus 1 into e power t plus c. Integration constant. Okay. So if you will get here the function, exponential function is e power minus 1 minus t, you will get here minus symbol, then t plus 1 e power minus t. Minus will be get common from this equation. If it is possible, if it is positive value e power t, you will get t minus 1 e power t. If it is e power minus function, you will get minus of t plus 1 into e power minus t. Okay, these formulas you will get in the session. Directly you have to write like this. Okay, so now we have to solve the formula problems. Okay, dy by dx plus y secant x is equal to tan x. Solution on comparison, p is equal to cos x, comparing with dy by dx plus py is equal to q. Comparing that equation, you will get here the coefficient of y is p, means p is equal to sec x is equal to q. The after equal to function is, you will get the q. So first you have to find what is the p, what is the q value. Then after write in the integration factor. Find the integration factor. The integration factor formula is e power integration of p dx. Now you will substitute the p value in this integration. So now integration of secant x formula already you know. Integration of secant x is equal to secant x plus tan x. So e power log of secant x plus tan x. Log of secant x plus tan x. So already we see in the formulas, e power log value is already 1. So therefore you will get secant x plus tan x. This is the required integration factor. Okay, I will explain once again. Then comparison of the given linear differential equation, we will get p and q values. After getting these values, we have to find the integration factor. Integration factor formula is e power integration of p dx. In this equation, you have to substitute the p value. We will get e power integration of secant x dx. Integration of secant x formula, you know, that is log of secant x plus tan x. Log of secant x plus tan x. So here this e power log x value is 1. So 1 into this one, you will get secant x plus tan x. This is the required integration factor. After completing the integration factor, then we have to go general solution. What is the general solution? See here, y into integration factor is equal to integration of q into integration factor into dx plus c. This is the required formula, general solution formula for the non-linear differential equation. So already we are calculated this integration factor. You know this q value. So substitute in this equation, we will get the general solution. Y into integration factor is secant x plus tan x. On right side, integration of q value already you know from the problem, tan x, and integration factor already we are calculated. So now in this term, you have to multiply it with the tan x, these two terms. It will becomes secant x tan x dx plus integration of tan square x into dx plus c. So this is already in formula, you know, integration of secant x tan x dx is equal to secant x. So it is not in the formula. So you have to convert this to tan square x 1 minus 6 sec square x minus 1. So see here, sec square x minus 1. This is already formula secant x. This can be written as integration of sec square x minus 1 from the fundamental identities in trigonometry. You will get secant square minus tan square is equal to 1. From that equation, you will get, from that identity, you will get secant square minus 1. Now it is ready to integrate. Integration of secant square x is equal to, you will write tan x. Integration of one value is x. So therefore secant x plus integration of secant square x minus integration of 1 dx, it becomes integration of secant square is secant x, tan x, it is mistake, sorry, secant x is already there. Integration of secant square is tan x, integration of 1 dx is minus x plus c. This is the general solution of the above problem. See here, y into secant x plus tan x from this equation is equal to, on right side, secant x plus tan x minus x plus c. After completing the solution, you have to put this plus c integration constant. Then it is the required solution. Okay, so see the second problem. Solve dy by dx plus y into secant square x, y into secant square x is equal to tan x into secant square x. Okay, tan x into secant square x. Okay, see here. So here, first you will careful examine this problem. Is it linear or not? See here, in the coefficient of y compulsory, it is in the variable x. On right side factor also compulsory in variable in x. And this is the first degree differential equation. And this y power also you will get 1 only. So is it a linear differential equation? Then you have to proceed. So here the coefficient of y is p. After comparing this dy by dx plus py is equal to q with the given differential equation, then you will get p value is equal to secant square x, and q value similarly on right side term is q. So that is tan x plus sec square x. Okay. So now we have to find the integration factor. The formula for integration factor is e power integration of pdx. Now in this e power integration of pdx, we have to substitute this p value in this equation. This equation becomes e power integration of sec square x into dx. Already you know this formula, integration of sec square is tan x. So e power tan x is the integration factor, required integration factor. Therefore, the general solution of the given linear differential equation is y into integration factor is equal to integration of q into integration factor into dx plus c, which is the general solution of the given differential equation. In this equation, we have to substitute this integration factor on left and right side. Then this equation becomes y into e power tan x is equal to integration of tan x into secant square x into e power tan x. I am substituting e power tan x on integration factor on left side and integration factor on right side. This is q term. Okay. Next step. So now we have to take this tan x is equal to t. Put tan x is equal to t. We will put in tan x is equal to t, it will be t and it will be e power t. So then after we will integrate derivative this tan x, it will become secant square x. Secant square x into dx. Secant square x dx is equal to, you substitute dt, and this t, this is e power t. So the equation becomes in the variable t, integration of t into e power t dt. This dt is secant square x dx, and t is tan x, e power tan x. Now it is ready to integration. So already we will discuss this formula in this session. So integration of t into e power t dt plus c using by Bernoulli rule, using by integration by part formula. Directly I tell in the session, t minus 1 e power t plus c, direct formula using by integration by part formula. This is the solution for this equation. So the equation becomes, so now substitute t value here, tan x minus 1 into e power t and e power tan x plus c. Okay, here the required general solution is, so this tan x here multiplying with y, and right side it is divides. So here tan x minus 1 plus c into, already c is there. So here dividing with e power tan x, e power tan x, e power tan x get cancelled. Here is 1, and here c by e power tan x. E power tan x take in numerator, we will get e power minus tan x. This is the required general solution. Okay. I hope you are understood well. So I will repeat once again this problem. See here, solve dy by dx plus y into secant square x is equal to tan x into secant square x. So now, if this equation is linear or not, we have to check once. So see here, first condition is given differential equation is first order differential equation. So this differential equation is power is 1. Okay, next y power is also 1. So first case is completed. And the second case is compulsory this coefficient of y and the right side terms are containing x terms or constants. Okay, in this terms we will get x variables only. So is this absolutely a linear differential equation? Then have to go procedure. So now compute comparing with the linear differential equation dy by dx plus py is equal to q. So in comparing these two equation, coefficient of y is p, that is p is equal to sec square x, and the right side term already I have to take this q. Okay, from the comparing of those two equations. So now the integration factor formula e power integration of pdx. So from the given terms you have to substitute by p value. So integration of secant square is tan x. You will get e power tan x. E power tan x is the integration factor of the above differential equation. Now we have to multiply this equation. It will becomes an exact differential equation. Then you have to get general solution. So therefore the general solution is y is equal to y into integration factor is equal to integration of q into integration factor into dx plus c. Dx plus c. This is the uh, general solution of the linear differential equation. Linear differential equation. Next, y into e power tan x is equal to integration of tan x secant square x into e power tan x into dx. See here in this equation we are substituting integration factor and q value also. Q is tan x plus tan x into secant square x. So in this equation it is uh, we, we don't have to solve this in this form. We have to change the variable by substituting t variable. See here, now you put tan x is equal to t, tan x is equal to t. Where the tan x is there, you have to put tan x. Then after tan x is equal to 2, we have to derivative this one. Derivative of tan x is secant square x dx is equal to on right side dt. See in this equation where the secant square x dx is equal dx is there, we will put replaced by dt. See here tan x we have to put here. Here also tan x we have to e power t. Then secant square x dx we have to put here dt. After derivating this equation you will get the secant square x dx. So now it is a variable in the variable in t. This integrand is in variable in t. This is in variable in x. Now it is ready to integrate using by integration by what formula. So already given formula like this function. See here t minus 1 into e power t plus c. We'll discuss in the session. Directly you have to write this formula. I will give an formula. Otherwise you have to using integration by what formula solve this one. You will get this answer. So now substitute in this equation t value. What is the t value? T is equal to tan x. Substitute here. Where the t is t function is there, you have to substitute tan x. You have to substitute tan x. Then the equation becomes like this. Here left side tan x is there. Take on right side. It divides the right side. See here on right side you have tan x. This tan x e power tan x is get cancelled. Okay, so tan x minus 1 you will get only this term. So here c terms also divisible by e power minus t. So e power minus tan you will take a numerator, you will get e power minus tan x. This is the general solution for the above linear differential equation. So I hope you are understood very well. So we will go to another problem. Okay, this is the required solution. Then what we learn in the session we will discuss once again. Okay, so see here we have learned so far about in this equation solving the differential equation, solving the linear differential equation, solving the linear differential equation of order 1. We will discuss in the session. Okay, next meaning of the integration factor. What is the meaning of the integration factor? What is the meaning of the integration factor? We'll discuss in the session. Finding integration factor. How to find the integration factor? We will discuss in the session. And write the general solution for the linear differential equation of first order. We will discuss about the general solution of the linear differential equation. So these topics are we will discuss in the session. These topics are we will discuss in the session. So next, today's quiz. The differential equation is dp by dv plus pv is equal to v is, see here, is this linear in P? Option 1. Next, linear in V? Option B. Linear in P and V? Option C. None. Option D. So in this four option, which is the correct solution? You have to choose the option. So see here, already you know which is the correct solution. So next, integrating factor of dy by dx plus py is equal to q is, see here, integration of e power pdx. B, option B is integration of e power pdy is option A. Pdx is option B, and integration of q dx is option C. Option D is e power q dy. These are the four options are given. So in this four option, which is the correct solution, we have to find out. See here, which is the correct solution, you know. So thank you everybody. So in this session, we have learned what is the linear differential equation, the form different definition for the linear differential equation, and the process of the finding the solution of general solution of linear differential equation, and definition of the integration factor, and formula for integration factor. Okay, formula for. So next, come two types of linear differential equations. We have seen the session. The first form is dy by dx plus py is equal to q, and the second form is dx by dy plus px is equal to q, where p and q are in variable in y. Okay, these two types of forms of linear differential equation we will see in the session. So how to find the integration factor, how to find the general solution of the linear differential equation, we have to see in the session. Some more important problems also we have solved in the sessions. Okay, so before this session, we have discussed the exact differential equation and homogeneous functions and variable separable methods. Okay, and non-homogeneous functions we have to discuss. We had discussed in the above the previous sessions. Okay, in this session we have completed uh, linear differential equations. Okay, thank you everybody. I hope you are understood very well. So we will meet next session. If you are any doubt in this session, please write the doubt in the chat box. Otherwise, comment. I will explain. I will give solution for you. I will clarify your doubts. Thank you. Thank you, everybody. Thank you to everyone. Okay. Good day. Have a good day.